were dealing with four kinds of fields. Those were called classical mechanics, quantum mechanics, special relativity, and quantum field theory. So what was classical mechanics all about? What was classical mechanics?
Newtonian physics.
Basically Newtonian mechanics.
So we were essentially dealing with Newtonian mechanics. That was for what was the condition to apply this mechanics? Velocities should be very much less than speed of light, and the body itself should be macroscopic. We cannot apply classical mechanics on subatomic particles or atoms. So if we want to apply on subatomic particles, then we have quantum mechanics. So subatomic particles moving with velocities which are again less than speed of light. So we could only address the smallness of the body in case of quantum mechanics. In special relativity, we deal with macroscopic objects, but those macroscopic objects can have velocities of the order of speed of light. Then last one is quantum field theory, in which we can deal with subatomic as well as velocities of the order of speed of light. So as of today, this is the most general theory, quantum field theory, and all these theories can be treated as special case of this generalized quantum field theory. Any doubts?
सर एक बार क्वांटम फील्ड में क्या होता था एज वेल एज के बाद
In quantum mechanics or quantum field theory?
सर क्वांटम फील्ड थ्योरी
Quantum field theory means you can apply this theory to subatomic particles moving with velocities of the order of speed of light. So this is what describes Higgs boson and whatever God particle, all those phenomena can be described by quantum field theory. Classical mechanics, quantum mechanics or special relativity cannot define those processes. And fluid mechanics, I am doing this only to help you find out that whatever you will be learning is only a small part of this domain, that is the classical mechanics. So we will not be dealing with whatever we study will not be applicable to subatomic particles, neither it will be applicable to bodies moving with the velocities of the order of speed of light. So our domain is fluid mechanics, and fluid mechanics is essentially a very small part of the entire regime called classical mechanics. Any doubts?
नो सर
So you should know your confines, that whatever you learn, you can only apply in certain set of operating conditions. You cannot apply those laws or extrapolate those laws in some other regimes. So that should be clear at the outset. So I'm moving forward now. So with this background, one more thing is that you might have heard about force is equal to mass into acceleration. So we have seen that this is a law that is only applicable in classical mechanics domain. So these kind of laws are called physical laws. So laws that are only applicable and they depend on the operating conditions, those are called physical laws, or also called effective models. So Newton's second law of motion is an effective model to find out the acceleration of a body which is macroscopic in nature and not moving with velocities of the order of speed of light. So this is just an effective model.
सर
Pardon
सर
me.
थोड़ा सा डेफिनेशन से लिखवा दो सर, इसका फिजिकल लॉ क्या बताया था आपने अभी?
Physical law is a law that is only applicable in a certain regime. For instance, F is equal to mass into acceleration is applicable only in classical mechanics regime. That is, if the body itself is not small and it is not moving with speed of light, then to describe the acceleration of the body, we use this model, and this is called Newton's second law. So this is generally called a physical law or also called an effective model. Likewise, anything you have studied, various kinds of laws, that is Archimedes principle and all that stuff, those are also called physical laws because their validity is not universal. They are only valid under certain set of conditions. But mathematical laws are the laws that are applicable irrespective of the domain you choose. So as such, we know that this gravitational constant, speed of light in vacuum, and Planck's constant, these values will remain the same whatsoever is the regime. So mathematical laws have universal appeal. Physical laws are only valid in a certain domain. And we will be primarily dealing with physical laws only because we are bothered only about laws that matter the most to a common man. And it should be clear in your mind, in nature, there are only 4 kinds of forces presently known to the science. So what does that mean? Presently, we know that any kind of force you see in your daily lives shall fall in either of the 4 categories. And I have written this in the decreasing order of magnitude. That is, strongest force, strong force is the strongest. Gravitational force is having the least magnitude. So can you let me know what do you mean by strong force?
सर एटम्स के बीच में.
So this is the force between subatomic particles. That is, protons and neutrons are held together by strong forces. Then what about weak forces? Weak forces are also
between molecules.
no. Weak forces are also operational at subatomic level, and their range is still lower. That is, they are only operational if the distance between the particles is 10 minus 18 meters. So weak forces are only there in this region.
सर न्यूक्लियस और इलेक्ट्रॉन के बीच में.
Pardon me?
सर between nucleus and electron.
Not exactly between, it can be between proton and neutron also, but the range is this. If the electron is very close, then this weak force may be operational. Strong force is operational in a distance of order of 10 minus 15 meters. So these are the
Yes, sir.
forces that you don't see in your daily lives, but they are there. So weak forces are responsible for radioactive decay.
बीटा डी के सर.
So any kind of radioactive decay happens due to these kind of weak forces in action. Then gravitational force, each one of you know. Then
Yes, sir.
electromagnetic force. So can you think about any kind of electromagnetic force in your daily lives? So if you are standing, you are exerting a normal force or the gravity is pulling you down. This surface is giving an equal and opposite reaction force. So what kind of force is this?
Electromagnetic force.
So this is
Strong
electromagnetic force.
force.
So all the forces that you perceive, for instance, I have two balls. They are colliding with each other. So if they collide with each other, what will happen is there will be momentum exchange between these two balls.
सर इलेक्ट्रोमैग्नेटिक फोर्स तो चार्ज पार्टिकल्स के बिटवीन होगा.
So it is between charged particles, but this normal force is also an electromagnetic force. So because you are standing on this, so this surface is exerting a force on you. Although it may not appear to be electromagnetic in that sense, but if you go into details of this, you will find that this essentially is an electromagnetic force.
Sir,
Yes.
can't that force be included in the strong force, because it's actually due to the interaction between the electrons of, अगर इस example की बात करें तो हमारे पैर के electrons and earth के electrons.
But
So
what there is, but what happens is this strong force vanishes when the distance becomes greater than 10 minus 10. So when you are standing on a surface, the surface roughness, the distance between the surface and you is far greater than this. If you see the surface roughness.
yes, sir.
So as such, strong force and weak forces are not operational in case of macroscopic bodies, because the order of distance is not that small in macroscopic bodies. So if I ask you, each one of you have seen a mirror.
Yes, sir.
So if I ask you, what is the surface roughness of this mirror? Do you understand surface roughness? That is, if this is a surface, what should be the order of, say this was the surface, what should be the order of this mountain and this peak, this trough? It is of the order of around 42 nanometer. That's why you feel a mirror very smooth. So the surface roughness of 42 nanometer means this distance is 42 nanometers. So you can think about it. The strong force vanishes at this scale. So when you are standing, strong force or weak forces are not operational. Only gravitational force and electromagnetic forces are operational. Is that clear? Is that clear?
Yes, sir.
At the order of 10 to the power minus 10 meters.
Meters. That is 1 Armstrong.
Okay, sir.
So this is again a perception that you feel that gravitational force is the most dominant force if we see our daily lives. But actually strong force is having the largest magnitude. Any doubts? So with this background, now we have finally reached our starting point That is, we will be now concentrating on fluid mechanics, and fluid mechanics is actually based on an assumption called continuum. So, any one of you is conversant with this concept of continuum?
Sir, no gap or voids between.
So there are no voids between
particles.
various atoms or molecules. So we treat, if we take some body like this, we treat the entire body as a continuous system so that we can define properties at each and every point without the fear that there will be some void there. So fluid mechanics is essentially based on this assumption. Clear? Now
Yes, sir.
you have studied rigid body mechanics.
Yes, sir.
What was the assumption in case of rigid body mechanics?
Sir, दो particles के बीच में relative motion नहीं होता है.
So particles, or say if this is a body, you choose any 2 points or any point, the relative distance between those points do not change. It remains the same. And that approximation is called rigid body approximation. So this is also an approximation because in actual practice, every body can deform. So for instance, you have a car that is moving in, say, right direction. Say this is accelerating with some acceleration A. You will treat the motion of this car as a rigid body motion. Although the deformation of this body might be there, but it will be negligible, so that you can treat this as a rigid body and get accurate answers, sufficiently accurate answers. So this was what you studied in mechanics course in first year. Now in this course, we are dealing with mechanics of deformable bodies. That is, we are dealing with bodies in which the distance between any 2 points you choose changes as force is applied or as the body is itself in motion. Or it may be at rest, the force is being applied on this body. If the distance between any 2 points is changing, that means this should be treated as a deformable body if that change is appreciable. If that change is not appreciable, then rigid body assumption is sufficient. Any doubts? And in deformable bodies, you can have solids, liquids, and gases. Solids and liquids together are called condensed matter. So now let me know, I'm writing down here. Do you understand the statement? Mass is condensed form of what? If I write down mass is the condensed form of what? What should I fill in this? Gases condense to form liquids and solids. If I say mass is the condensed form of, what should I say? Of what?
Atoms.
I'm giving you a hint here. If you try to
Of light.
Energy.
of energy. So try to think about it. Mass is nothing but, again, condensed form of energy. Like solids and liquids are condensed form of gases, in a more general framework, mass itself is condensed form of energy. Now, to deal with mechanics of deformable bodies or rigid bodies, you have essentially these four things. That is statics, kinematics, dynamics, constitutive relationship. And this should be understood in the light of the fact that something causes and there is some effect of that cause. For instance, say you were standing on the rooftop, you throw a ball, the ball will follow a path, and we know that this path is more or less a parabolic path. Now let me know, what is the force acting on this ball as it is moving in this direction?
Gravity.
Gravity. I'm considering another example. I'm throwing ball simply by dropping the ball from a height. What is the trajectory?
Parabolic.
If you throw a ball without any initial horizontal velocity, what will be the trajectory of the ball?
Straight line.
Straight line, vertical.
Straight line.
Here also forces acting is mg.
Gravity.
So let me know, why do you have different trajectory in both the cases, although the force is same?
The angle of projection is different.
सर फेंकने का जो स्टाइल है सर, थ्रो करने का स्टाइल डिफरेंट है ना सर हमारा.
So in cause, in addition to force, what else should be there?
How we
Direction.
are direction, angle, how we are throwing.
I am writing down a more general term, initial condition. So in this case, initial condition was a velocity v horizontal. In this case, initial condition was velocity 0. So cause of any kind of motion is force and the initial condition. Any doubts? Any doubts?
No, sir.
Now this could be described by force is equal to mass into acceleration. Now this is the cause in addition to the initial condition. So this part is called dynamics. This trajectory, this acceleration is what? This is second order derivative of this.
सर सर जो आपने ये लिखा है फोर्स एंड इनिशियल कंडीशन, ये आपने पहले वाला बताया, स्टैटिक्स का बता रहे हो आप सर? ये एग्जांपल
ये डायनेमिक्स का,
इसमें डायनामिक्स का बता रहे हो आप.
force and initial conditions. If you want to study force and initial condition, that study is called dynamics. Clear?
Yes, sir.
If you want to study the trajectory, that is the displacement, velocity, acceleration of this motion, that part is called kinematics. That is acceleration. In this case, it is acceleration. That is second order derivative of the displacement. And these two are related together with a material property. This is a material property. That is the mass. And this relationship itself, that is force is equal to mass into acceleration, is called the constitutive relationship. That is the relationship between dynamics and kinematics through a material property. That relationship itself is called a constitutive relationship. Any doubts in kinematics, dynamics, and constitutive relationship? Any doubts? And statics is only a special case of dynamics with velocity equal to 0. So that is the statics part.
सर वेलोसिटी कांस्टेंट अगर होगी तो तभी तो स्टैटिक है।
क्या कह रहे हैं आप?
सर वेलोसिटी 0 है सर, अगर वेलोसिटी अगर कांस्टेंट है तब भी तो
if you can
स्टैटिक्स
say
में आएगा।
velocity 0 or velocity is say constant, then also you can apply this statics principle. Velocity 0 or velocity constant leads to statics. Kinematics is studying the cause, and the cause includes force as well as initial conditions. And due to that cause, there is some effect. Effect is there is some kind of motion. And that motion itself, the study of that motion is called kinematics. And the relationship between this dynamics and kinematics is through some material property, that is mass in the present case. And this relationship is called constitutive relationship. Any doubts?
No, sir.
This was the case of a rigid body mechanics. Now let me know, say I have a bar to which I apply some load. Due to application of load, it has deformed by some amount delta y. So have you heard about this relationship? Have you heard or read about this
Stress.
relationship?
Yes, sir.
Yes, sir.
Hooke's law,
Stress
sir.
is proportional to
Strain.
strain. This was Hooke's law. Now let me know what is the dynamics part here, static parts here, and material property here.
ये जो है सर ये है यंग्स मॉडुलस है वो मटेरियल प्रॉपर्टी है।
So this is called material property.
और जो सिग्मा है सर सिग्मा डायनामिक्स में नहीं एप्सिलॉन डायनामिक्स में आ जाएगा एप्सिलॉन।
नहीं, ये डायनेमिक्स में आएगा. This is the cause.
डायनेमिक में आएगा और एप्सिलॉन सर काइनेटिक्स में.
This is kinematics. And this is called constitutive relationship. So we have first as taken example of a rigid body mechanics. Now this is deformable body mechanics of a solid. So you can see the common thread in all these seemingly different examples. Now I'm taking up the last example here. Say you have a bar and you have kept this part on fire. What will happen? There will be increase in temperature in this bar. And if you know that this heat flux is equal to minus K dt by dx. Have you heard about this law?
Yes, sir.
This is Fourier's law of heat conduction. Now what is the dynamics part here? You are applying heat at one end. Due to this application of heat, temperature of the points in the body is increasing or changing.
Sir, dt by dx dynamics part हो गया शायद.
नहीं सर.
No, this is kinematics.
Yes sir, ये kinematics है. Q है सर dynamics. Q dynamics.
This is dynamics.
और K वाला material property हो जाएगा.
Material property. Now try to see the beauty of this common thread. This kind of symmetry, that is, you have dynamics part connected to kinematics part through some material property, is applicable whether it is rigid body mechanics, deformable body mechanics of a solid, or a heat transfer problem.
सर ये दोबारा एक्सप्लेन कर दो यहाँ पे काइनेमेटिक्स और डायनामिक्स कैसे हो गया.
जैसे अब क्या है, टेम्परेचर है
जी.
जैसे पहले केस में क्या था, उसका मोशन था फर्स्ट केस में.
यस सर.
ठीक है, यहाँ पे आपने हीट अप्लाई करी, उसकी वजह से क्या चेंज हुआ, यहाँ पे कौन सी प्रॉपर्टी चेंज हुई? नॉट अ प्रॉपर्टी, मतलब टेम्परेचर चेंज हो गया इसका हर जगह. एंड दिस इज फर्स्ट ऑर्डर डेरिवेटिव ऑफ द टेम्परेचर.
यस सर.
So this is the effect of applying this heat. That is, temperature is changing with respect to x.
Yes, sir.
So this is kinematics, this is dynamics, and this is the material property. So all seemingly different examples have something common in them. That is, each one of them has
सर आपने
dynamic.
कहा था कि सर आपने कहा था कि डायनामिक्स से डिपेंड करता है इनिशियल कंडीशन के ऊपर
हाँ,
और फोर्स के ऊपर, है ना?
ठीक है.
तो सर इस एग्जांपल में बाहर वाले केस में इनिशियल कंडीशन और फोर्स के ऊपर कैसे हीट पता कैसे डिपेंड कर रही है सर? तो क्यू डबल डैश है.
अच्छा, मैं आपको एक सेकंड रुको, एक मिनट. मैं हीट वाला एग्जांपल बताऊं आपको?
बता दो सर एक बार.
ये मान लो ये है मेरे पास, दो केस ले लिए. एक बार मैं इसको फ्रिज में से लेके आया था, मैंने इसको एकदम से इस पार्ट को मैंने हीट प्रोवाइड करनी शुरू कर दी, इसको आग के ऊपर रख दिया. दूसरा मैं क्या आया, मैं धूप में ऑलरेडी पड़ा था, मैं इसको लेके आया. तो इसमें क्या होगा, टेम्परेचर इनिशियली डिफरेंट होगा. हाँ जी,
हाँ सर होगा अलग टेम्परेचर है इसका.
तो अगर मैं टेम्परेचर प्लॉट करूं along x, दिस इज L, दिस इज ऑल्सो L, तो दोनों केस में क्या होगा, टेम्परेचर फील्ड कैसी होगी, डिफरेंट होगी.
यस सर होगी. अच्छा हाँ सर समझ गया मैं. सर समझ गया. टेम्परेचर मतलब उसका अलग है तो उसकी इनिशियल कंडीशन अलग है, उसकी इनिशियल कंडीशन अलग है.
हाँ, तो यू विल
लेकिन हम
हैव फाइनली गेट डिफरेंट.
फोर्स, और लेकिन यहाँ पे हीट जो है वो फोर्स का काम कर रही है.
हाँ, is that clear?
यस सर.
So I will break for today. Any doubts, please ask me.
सर
हाँ जी,
सर ये जो लिंक है सर परमानेंट लिंक है?
कौन सा लिंक?
सर इस मीटिंग की, इस जूम मीटिंग की सर जो ये लिंक है परमानेंट लिंक है क्या?
हाँ, ये परमानेंट लिंक है.
सर फुल वीक मतलब चेंजेस नहीं है ना इसमें?
चेंजेस नहीं है.
एंड सर इसमें एक बार सब ग्रुप्स भी बता दीजिए कौन कौन से सब ग्रुप्स है, कॉज अभी आधे सब ग्रुप वाले सर उस मीटिंग में अटेंड करके आ गए.
ME 7, 7, 8, 9 and MP 1.
Okay.
ME 7, 8, 9, MP 1. I have also written down on the LMS screen. If you go
Yes,
to LMS
sir.
screen, this is mentioned there.
Right, sir. Thank you.
Okay then. Okay. I am ending the meeting now. I am logging out. You will be joined by the next teacher.
Thank you, sir.
Okay.